Hello and welcome back to class. This lecture is going to be over section 5.6. It's actually the only section we cover in chapter 5. We just talk about the exponents and scientific notation section of that, so we kind of jump over and capture that, and then we'll go back to another chapter. But anyway, this is still part of module 1, so follow along with me with your note packet, if you will. We're going to talk about exponents first. So notice that we first of all talk about the importance of a parenthesis. So in this first example, 3 to the second equals 9. There is no parenthesis, so there's nothing to worry about here. This simply means 3 squared means 3 times 3. The squared tells how many 3's are involved and multiplied, so there's 2 3's. The 3 is what's being multiplied together, so 3 times 3 to equal the 9. The next example, we see -7 without a parenthesis, and there's actually a typo there. So please fix that on your notes. It should say equals -49. So the point I wanted to make here is if there is no parenthesis around this, so still no parenthesis is shown up, and you have a negative sign, this is like saying a -1 multiplied onto whatever we're talking about. So there's a -1 multiplier times the 7 squared. So all that's really getting squared is the base 7. We would say 7 is the base. So 7 squared means 7 times 7, which we know is 49. And then there's a multiplier of a -1 in front of that, which makes it then -49. So a negative, you might have heard people say a negative squared is positive, but not so if it's not part of the base. If it's not in parentheses, it's a negative multiplier. On all of these, as we go through them, I would encourage you to check them on your calculator as well and type this in without a parenthesis, just as it's written here. Again, back to its original form, it looks like this. Minus sign, then 7 squared. If you type that on your calculator, it should verify the -49. And again, that's because this negative sign is not part of this base. It's a negative, kind of afterthought, a negative multiplier. The 7 is being squared, which is truly 49, and then we put the negative sign on kind of after it, after the exponent. So that, in that case, a negative squared, the negative is not really part of the squaring, it's a weighting negative there. It does remain negative. The next example, 100 to the first power, that anything to the first power just means the one of it that there is, so it just equals itself. It's sort of like you could say that's an understood 1 and drop it. The next example, 5 squared. So back to just a typical problem, a regular number, no negatives, no parentheses to worry about. That just means 5 times itself. 5 squared means 5, 2 5s. 5 times 5, which is 25. The next example, -5 squared. Back to this again. This is that weighting negative I mentioned before. It is not part of the base, so it's just the 5 is squared, which we know means 25. Then the negative sign put on at the end makes it -25. So written like this, it is -25. All right, now here's where we get into using the parentheses, the difference a parenthesis makes. The next example on your paper has a parenthesis around the negative sign. So this is saying, we're talking now about the number -7, and the negative is part of the base. So the negative is being squared, as designated by having that parenthesis. So this means the number -7 2 times. -7 squared, the whole thing is squared. -7 times -7. So a negative times a negative, we do know from our rules means it's a positive. A negative is positive. All right, the next example, 1 raised to the 100th power. That would mean 1 times 1 times 1. I will not write this 100 times, but I just want to get the idea out there. 100 times. 100 ones there times itself. Well, 1 times itself, however many times, is still going to be just 1. So that nets just 1. And you again check this on your calculator. You'll use either the up arrow to make an exponent, 1 raised to the 100th power, or some calculators have this x to the y or y to the x button. That's your exponent function key. So 1 exponent 100. Just check that on your calculator. Get a calculator you're comfortable with and practice using that. and be handy with that. They're all just a little different, so it's good to get one and practice with it. All right, 1 raised to the 100th power, or 1 raised to any power, is always going to be 1. The next example, 4 to the 3rd, that means 4 times 4 times 4. Again, that means 3 fours. 4, 4, 4 times together. So 4 times 4 is 16. 16 times 4 is 64. 64 there. Again, practice that on your calculator. 4 raised to the 3rd. The next example, we have a parenthesis around the negative sign. This means the negative 5 is actually being squared. Negative 5 times negative 5. The negative is part of the squaring here. Negative 5 multiplied by negative 5. So 2 negative 5s multiplied together makes a positive 25. And then lastly here, leaving the parenthesis off, back to this again. When there is no parenthesis, the negative weights. The negative is not part of the squaring. It's like a negative 1 multiplied in front of that. So we do the squaring, get 36 for that, and then tack on the negative sign as an afterthought, or just know it's going to be negative because the negative is kind of a standalone negative, a negative 1 in front of whatever the exponent answer is. All right, so the parentheses tell us the value of the base. What's in the base, what is going to be multiplied. The negative sign, if the negative sign is not included in the parentheses, then it's not part of the base and therefore does not get the exponent applied. I call this a weighting negative, this idea of not being in the parentheses, that negative weights is kind of put on at the last afterthought. It is really a negative 1 multiplier, and we know from order of operations that exponents have to be done before multiplication. So we do this exponent first, then we multiply by the negative sign. So it's a little subtle different there. I just want to make a big point of that because it comes up a lot as we do problems. Okay, the next thing we're going to go through are these rules of exponents. We have a list of rules here. The first rule of exponent is called the product rule. So number 1, product rule. The product rule says if you have any base raised to a power times that same base raised to a power, then that is equivalent to bringing the base over and adding the powers, m plus n. Some examples of that, 2 to the 3rd times 2 to the 2nd. So this follows that pattern. You've got the same base, like bases, and you're multiplying. That means you can add the exponents. So we bring over the base, add the exponents, 2 to the 5th. This can be worked out or left as such right now. That's just fine. The next example, 5 to the 2nd times 5 to the 4th. Again, you have like bases. So same pattern here, like bases and multiplying. You can add your exponents, 5 to the 6th. The next example you see on your paper, negative 2 to the 3rd times negative 2 to the 1st. Again, like bases, multiplication means you can add these exponents. So always bring the base over just as it is, and then adding these exponents. That could be worked out if requested, like the problems we were doing earlier. This negative is in a parenthesis to an even amount of times. So a negative to an even power, that will be positive. And you can verify that on your calculator. I want you to practice these as well. And then lastly, 3 to the 3rd times 3 to the 4th. Like bases and multiply follows our pattern. We bring the 3 over, add the exponents, 3 to the 7th. And again, all these could be worked out if requested. Sometimes they just ask you to leave it like that, depending on your directions. So that's the product rule. Okay, the second rule with exponents is the quotient rule. Quotient means divide in math class. So the second one is what happens when we're dividing like bases. So we have an a to the m divided by an a to the n. So if you have this like base situation, and again, a just stands for, it could be any number. This applies to all real numbers. When you have like numbers, like bases, you can subtract top minus bottom. So it'll be the base and then m minus n. Some examples of that, we have 5 to the 8th over 5 to the 5th. Because they're like bases, we can subtract 8 minus 5, bring the base over the 5. 8 minus 5 is 3, 5 to the 3rd. Next, we have 8 to the 12th over 8 to the 5th. So again, because we have like bases, we can write that base over here, 8, and subtract 12 minus 5, 7, 8 to the 7th. And then one more example here. 5 to the 2nd over 5 to the 4th. This time when we subtract, we're going to be in the negative, in the red, right? So 2 minus 4 is going to give me a negative 2. Now normally we won't be leaving negative exponents on answers. It's not really considered in final form when you do. So, but we'll talk about that in a later rule in a minute. Okay, the third rule is the zero exponent rule, and it says if you have any base raised to the 0, that simply equals 1. Any number, and check it on your calculator, I keep telling you, do 7 to the 0, 2 to the 0, whatever number you can think of, raise it to the 0 power, it always equals 1. That is just a solid rule, math fact. So some examples, 2 to the 0 is 1, 3 to the 0 is 1. Negative 7, which is also a number, right? A negative number, and it is included in the parentheses, so we're talking about the number negative 7. Check that out, it's also 1. But we know if the parenthesis is not around a negative sign, that's a weighting negative. That is not part of that exponent. So this weights, this answer is 1, and then the negative put onto that makes it negative 1. You can check that on your calculator. What if we wrote 5x to the 0? There's a little subtle multiply right between those. So we do x to the 0, anything to the 0 is 1, and then times 5 makes that 5. And then lastly, if it's in parentheses, anything in parentheses, any value raised to the 0 is 1. All the parentheses designate all this stuff is raised to that power. That's what goes to that power. Okay, rule number 4. This is where we learn what to do with that negative exponent I mentioned earlier. We're never supposed to leave a negative on an exponent. So if you wind up with a negative exponent, you write it as a fraction, 1 over this stuff. And it makes that positive then. So whatever your exponent is, if it's negative, bring it to the denominator, write it as a fraction, and it'll make your exponent positive. So for example, if you have 2 to the negative third, that will be 1 over 2 to the positive third, which could also be written as 1/8. If we have 5 to the negative 1, that is 1 over 5 to the positive 1, or 1/5. Now when you do your homework, you'll see this comes up in your homework, and you might be tempted to write this as 5 raised to the negative 1 comes out to be a decimal 0.1. That will not be the appropriate answer here because we're testing whether you can write it in this form. So make sure you follow the directions. It says no decimals. Normally decimals are fine, but sometimes we're trying to test something else, and I want you to be able to understand this rule that the negative exponent makes it a fraction, so you can be able to write it as a fraction. Okay, one last rule to be aware of is the power rule, rule number 5, last rule for exponents that we cover. If you have a power raised to a power, those powers multiply and become a to the m times n. So for example, 5 to the 4th raised to the 3rd would be 5 to the 12th. Again, multiplying your exponents. 7 to the 2nd raised to the 5th is 7 to the 10th. So multiply exponents. You have some activity. You can pause the video to practice those. But as always, I keep going on with this, but I expect you to pause and work this. The answer to the first one should be 3 to the 5th. The second one should be 1. The third one is 1. The fourth is negative 1. Fifth is 6. Sixth, the answer should be 1 over 49. And 7, 1/16.